Variables are fundamental building blocks in JavaScript that serve as containers for storing data. They are essential for managing state, handling data flow, and creating dynamic applications. In this comprehensive guide, we'll explore different ways to declare variables and understand their behavior in various contexts. There are three main ways to declare variables in JavaScript. They are var, let, and constant. Var is represented by a box icon. Let is represented by a lock icon, and const is represented by a diamond icon. Here is an example of how these are declared. The keyword var followed by a variable name message is assigned the string value hello. The keyword let followed by a variable name count is assigned the number value 42. The keyword const followed by the variable name pi is assigned the floating number 3.14159. Variables declared with the keyword var have certain characteristics. They are function scoped, meaning they are accessible within the entire function they are declared in. They are also hoisted, which means their declarations are moved to the top of their scope during execution. They can be redeclared, allowing the same variable to be declared multiple times. Also, when declared outside functions, they create a property on the global object. Here is an example of function scope. Inside the function named example, a variable x is declared using the var keyword and assigned the value 1. Inside an if block, the variable x is again declared and assigned the value 2. This is still the same variable x. The console logs will output 2 and then 2 again since this variable is function scoped. Here is an example of hoisting. When you try to access the variable message before its declaration, you get the value undefined. It is equivalent to declaring the variable first before accessing it, and then assigning a value later. Using var can lead to unexpected behavior due to hoisting and function scope. It's easy to accidentally redeclare variables or access them before initialization. Modern JavaScript favors let and const for better scoping control. Variables declared with the keyword let have different characteristics. They have block scope, meaning their accessibility is limited to the block they are defined in. They cannot be redeclared within the same scope, but can be reassigned new values within their scope. In this function named example, the let keyword is used to declare a variable x and assign it the value 1. Inside the if block, a new variable x is declared with the let keyword and assigned the value 2. This is a different variable x than the one outside the if block. The console logs will output 2 and then 1. Variables declared with let are block scoped to the loops also. The difference between let and var can be seen in the setTimeout example. In the first example with let, the numbers 0, 1 and 2 are outputted. In the second example with var, the number 3 is outputted 3 times. This happens because var variables are function scoped, and during the loop, the setTimeout function keeps a reference to the same variable I. The temporal dead zone or TDZ is the period between entering the scope and the actual declaration where the variable cannot be accessed. This behavior helps catch potential reference errors early in development. Variables are not initialized until their actual declaration is reached. Accessing variables in the TDZ throws a reference error. This promotes cleaner coding practices by preventing access before declaration. Variables declared with the keyword const have immutability rules. You cannot reassign const variables. You cannot redeclare const variables. Const variables must be initialized at declaration. Const variables are block scoped like let, and also respect the temporal dead zone or TDZ. They provide an additional layer of immutability by preventing reassignment. Here we see a visual example. A const variable x is declared with the value 5. When you try to reassign the value to 10, you get an error. Const variables provide immutability, but this immutability is only for the variable itself, and not the content of the variable. The content of objects and arrays that are assigned to const variables can be modified. For example, const user is declared and assigned an object with the properties name and age. The age property can be changed to 31, and a new property named city can be assigned to it. However, the user variable cannot be reassigned to a new object. Similarly, in arrays, the push method can be used to add elements to the array, and the element at index 0 can be changed. However, the variable number cannot be assigned to a new array. Const only prevents reassignment of the variable identifier. The content of objects and arrays can still be modified because const ensures that the reference or pointer remains constant, not the data it points to. Variables declared with the keyword var have function scope, meaning that they are accessible throughout the function, ignoring the block boundaries. In this example, a variable x is declared using the var keyword and is assigned the value 1. Inside an if block, a variable x is declared using the var keyword again and is assigned the value 2. This is the same variable x and the value gets overwritten. Another variable y is declared using the var keyword and is assigned the value 3 inside the if block. This variable is also accessible outside the if block. The var keyword is hoisted to the function scope as well. The declarations are moved to the top of their scope. Variables declared with the keyword let and const have block scope, meaning they are accessible within the block of code they are declared. In this example, a variable x is declared with the let keyword and is assigned the value 1. Inside an if block, a variable x is again declared with the let keyword and assigned the value 2. These are two different variables. A const variable y is also declared inside the if block. This is scoped to the if block only. If you try to access the variable y outside of the if block, you get a reference error. The let and const keywords respect the block boundaries, providing better encapsulation and preventing variable leakage. Variables declared with the keyword var, when declared outside of functions, create a property on the global object. In a browser environment, this global object is the window object. A variable declared with the var keyword named global var is accessible as a property of the window object. Variables declared with the let keyword do not create a property on the window object. If you accidentally forget to declare a variable with the keyword var, let or const, it is assigned to the global scope. Using global variables can cause issues. It may lead to name collisions with third-party scripts, memory leaks due to persistent references, difficulty in tracking variable modifications, and reduced code maintainability. Variables declared with the keyword var create a property on the window object and can be accessed globally. Variables declared with the let or const keyword do not create a property on the window object. They are scoped to the module or the script. To avoid global pollution, use modules to encapsulate variables and prevent global scope leakage. In this example, the config variable is exported from a module file and imported into another file. Use the module pattern for legacy code. This creates private variables that cannot be accessed directly. Always declare variables with const or let instead of var. Also use strict to prevent accidental global variable creation. Naming variables correctly can greatly increase readability. There are certain conventions that are followed when naming variables. When naming variables and functions, the camel case convention is used, where the first word is in lowercase, and all subsequent words are capitalized. When naming classes or constructors, the Pascal case convention is used, where all words are capitalized. When naming constants, the upper snake case convention is used, where all the words are in uppercase and separated by underscores. When naming private or internal variables, an underscore prefix is used. Here are some examples of variable names following the conventions. When choosing variable names, it is best to be descriptive but also concise. Here are some examples of variable names that are either too vague or too long, along with the right way to name them. Also, use intention-revealing names. The name of the variable should reveal what it is used for, rather than how. Here are some examples of unclear variable names and clear variable names. Also, it is good to use a consistent vocabulary throughout your codebase. For example, use the same word for fetch or get when dealing with API calls like get user data and get product data. There are several ways to declare variables. When declaring variables, use one variable per declaration. This promotes clarity and makes it easier to add or remove variables without dealing with commas. Another way to declare variables is using comma-separated declarations, where multiple variables are declared in one statement. This can be more concise, but can be harder to maintain. Use this with caution. A modern way to declare variables is using destructuring declarations. This allows to extract values from objects and arrays easily. When initializing variables, you can use the immediate initialization, where variables are initialized with literal or computed values. Another way is using lazy initialization, where the variables are declared first and initialized later, depending on a condition. When initializing variables, it is best to initialize them as close as possible to their usage. Use const by default and let when reassignment is needed. Provide meaningful default values when appropriate. Also consider using nullish coalescing, which is represented by 2 question marks, for fallback values. The memory lifecycle consists of 3 steps. First, memory is allocated when variables are declared. Second, reading and writing operations are performed on these variables. Finally, the memory is freed when the variables are no longer needed. The JavaScript engine uses garbage collection to release unused memory. One of the algorithms it uses is reference counting. In this diagram, you can see Object A has 2 references. Object B has 1 reference and Object C has 0 references. Object C is eligible for garbage collection. Common memory leaks include forgotten event listeners, circular references, closures holding references, and global variable accumulation. When variables go out of scope or their references are removed, the JavaScript engine's garbage collector identifies and frees the memory. For example, when the function ends, the variable obj goes out of scope and is available for garbage collection. Also, nullifying references makes the original objects available for garbage collection. To prevent circular references, you need to break the circular reference by setting the objects to null. Here are some of the best practices when dealing with memory. Reset references when they are no longer needed. Use const for immutable references. Remove event listeners when components unmount and avoid creating unnecessary closures. Weak maps can be used for better memory management. It is best to use const by default and let when reassignment is needed. Avoid the use of var for better scoping control. Keep variables in the smallest possible scope and avoid global variables. Use descriptive names with proper casing conventions. Clean up references and event listeners. Use weak map or weak set when appropriate. Here is a quick reference guide, which summarizes the important points that were discussed. Const is used for immutable binding. Let is used for block-scoped mutable variables, and var is used for function-scoped hoisted variables. Let and const provide block scoping. Var provides function scoping. Modules provide a way to export and import variables. Single declarations, destructuring, and module exports are some of the declaration patterns. It is important to clear unused references, avoid memory leaks, and use appropriate data structures. Key takeaways include using const and let over var, respecting block scope, giving clear names, being memory conscious, having proper initialization and module organization. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.